This lesson focuses on subtracting rational expressions with the same denominator. Now, in the previous lesson, we looked at adding rational expressions with the same denominator. In this lesson, we're going to look at subtracting. Now, just like we did with the previous lesson, we looked at one example where we were adding fractions with the same denominator. Let's do the same thing with subtraction. So, for this problem, let's look at, and remember we're subtracting rational expressions here. So this will be subtracting two fractions. So let's suppose we had 7 eighths minus 3 eighths. All right, so remember when you're subtracting fractions or adding fractions for that matter, before you can write this as one rational expression or one fraction, the denominators have to be the same, and they are. So once you get the denominators to be the same, then all you do is subtract their numerators in this case. So 7 subtract 3 will be 4. So I'm going to get 4 eighths, and then 4 eighths reduced gives me 1/2. Okay? So when subtracting or adding rational expressions or fractions in this particular case, before we can combine them into one rational expression, the denominators have to be the same. And so in this lesson, all of the denominators are the same. So we're going to be subtracting in this case. So the directions will say, to the effect, subtract. And so let's look at number 1. So number 1, we have 3x plus 2 divided by 5, and we're subtracting 7/5. All right, so I have these two rational expressions, and I want to subtract them. All right, now notice the denominators are the same. So therefore, that means I can write this as one rational expression with that denominator of 5. Now, what I would do is go off to the side and actually subtract the numerators. So in other words, we have 3x plus 2 subtract 7. And so then combining like terms, I get 3x minus 5, because a positive 2 and a negative 7 is a negative 5. So the answer is going to be 3x minus 5. Now remember, the next thing you want to do, just like we did when we added rational expressions, once we write this as one rational expression, then we want to factor and then reduce if possible. Okay, so if I look at what I have, I can't factor the numerator any further, and there are no common factors, so this is the answer. Okay? All right, number 2. Number 2, we have x plus 8 divided by x minus 1, and I will subtract this rational expression, which is x divided by x minus 1. So again, notice that the rational expressions have the same denominator. Since they have the same denominator, that means I can write this as one rational expression with that denominator. I just need to go off to the side and figure out what the numerator is going to be. So I have x plus 8, and I am subtracting x. Then combining like terms, the x's add up to be 0, and you're left with 8. So I get 8 divided by x minus 1. At this point, remember when you dealt with simplifying rational expressions in a previous lesson? So to simplify this rational expression, you need to be able to factor and then divide out common factors. And in this case, in both cases, I can't factor any further. And the factor of 8, there's no factor down here that will reduce with it. So this is it. That's your answer. Okay? Number 3. Number 3, we have 2x minus 3 divided by x plus 5. And then I'm subtracting 3x minus 7 divided by x plus 5. Okay, so what I would do, and in this one you really need to be a little bit careful with the subtraction here. If you notice the first two, I was subtracting a monomial factor. I was subtracting a monomial factor. All right, so I didn't have an issue. Okay, now in this case though, I am not subtracting a monomial factor. I'm subtracting a binomial in this case. So I am subtracting a polynomial with with two terms and not a polynomial with one term. So what you need to do is do this step here, and then I'll show you what you're going to have to put. But just remember, since I am subtracting two rational expressions with the same denominator, just like you did when you added two rational expressions, you're going to write this as one rational expression with x plus 5 as a denominator. All right, now here's the way you need to deal with the numerator. Okay, so I have 2x minus 3, the first numerator, and you need to go off to the side and do that. Don't do this in your head. You may mess up. So actually write it out because you can see what you're doing. You can physically write it. Minus, all right, now I am subtracting all of this. You see, if you did this, if all you wrote was this, then that means that I am subtracting just a 3x. Okay? And then when you combine like terms, what you put here is going to be incorrect. Because you are not just subtracting 3x, you are subtracting 3x and a negative 7. That's what you're subtracting. So when you're subtracting, and this is a polynomial with more than one term, in this case it's 2 or 3 or whatever it may be, put that in parentheses. That becomes very important. And now distribute. Notice what happens. I get 2x minus 3 minus 3x, and then the opposite of a negative 7 is a positive 7. And now notice when I combine like terms, 2x minus 3x is a negative x, a negative 3 and a positive 7 is a positive 4. Okay, so I get negative x plus 4. And to simplify this, you'll notice that the denominator and numerator I can't factor, so I would just leave this alone. So that's your answer. Okay, so just remember, whenever you are subtracting a polynomial with more than one term, put it in parentheses. Okay? All right, number 4. Number 4, we have 2x plus 4 divided by 6x squared minus x plus 5 divided by 6x squared. All right, so 2x plus 4 divided by 6x squared minus x plus 5 divided by 6x squared. Okay, so again, notice that the denominators are the same, so I can write this as one rational expression with 6x squared as a denominator. The numerator, I'm going to do it just like I did this. That becomes very important that you put that in parentheses, because you are saying 2x plus 4 subtract this numerator. So you're subtracting all of the terms in the numerator. So you're subtracting x plus 5. That's what you're subtracting. You're not just subtracting x, you are subtracting x plus 5. So notice the parentheses. And now you're going to get rid of the parentheses just like you did in previous lessons or previous courses. And so you get 2x plus 4, subtract x, and then minus 5. And then combine like terms, 2x and a negative x is x, 4 and a negative 5 is a negative 1. And so that's the numerator. So this becomes x minus 1 divided by 6x squared. And I can't factor that and I can't reduce it. So that's your answer. All right, so number 5. Number 5, let's suppose we have this problem. We have 5x plus 2 divided by 2x minus 3 times x plus 5, and I'm subtracting 3x plus 5 divided by 2x minus 3 times x plus 5. Okay? All right, so notice that in number 5, the denominators are the same, and they're already in factored form, aren't they? So they're in factored form. So I'm going to rewrite this as one rational expression with that denominator. So the denominator, I'm going to leave it in factored form. So 2x minus 3 times x plus 5. Now let's figure out what the numerator is going to be. So the numerator, I'm going to subtract this numerator from this numerator. So I'm going to say 5x plus 2 subtract this polynomial, so that's 3x plus 5. Distributing the negative 3 here, I get 5x plus 2 minus 3x, and then minus 5. And then combine like terms, I get 5x and a negative 3x is 2x. A positive 2 and a negative 5 is a negative 3. And so that's the numerator. So that's this. Okay, so then the next step, once you write this as one rational expression, remember the next step is to factor. And notice that the numerator I can't factor, and the denominator is already factored, right? And so the next step after that is to reduce. So do you have any common factors? Yes, you do. 2x minus 3 and 2x minus 3. So those divide out. Remember, I always put ones in their place. And so the answer is 1 divided by x plus 5. That's the answer. All right, so that's number 5. Let's look at number 6. All right, so number 6, we have this for number 6. We have x squared plus 2x minus 10 divided by x minus 7, and that's being subtracted by this rational expression, 6x plus 11 divided by x minus 7. All right, so again, notice that the two rational expressions have the same denominator. So then I'm going to write this as one rational expression with that denominator. And then all I need to do is, first of all, subtract our numerators. So let's go ahead and write it out. Actually, write it out. When you're subtracting, write it out. It helps. So I get x squared plus 2x minus 10. And then I'm subtracting, in parentheses, 6x plus 11. Okay? And then distributing, get rid of the parentheses. I get x squared plus 2x minus 10 minus 6x minus 11. Okay? Then combine like terms, I get x squared, and then 2x and a negative 6x is a negative 4x, and I'm putting in descending order. And then negative 10 and a negative 11 is a negative 21. So that's the numerator. So x squared minus 4x minus 21. Okay, now once you get to that point, remember, what's the next step? With all that we've talked about with adding and subtracting, what is the next step? The next step is to factor and then reduce. So let's go ahead and factor this. The numerator, it looks like I can factor that as x minus 7 times x plus 3. Yep, that's correct. And then the denominator, I can't factor, so I'm going to leave it as it is. And then notice, what can you do next? You can reduce the x minus 7s. So the x minus 7s, the factors of x minus 7 divide out, and you're left with just 1 times x plus 3, which is x plus 3, divided by 1, so you get x plus 3. That's your answer. Okay? Number 7. We have, for number 7, we have this. We have s minus 3 divided by s plus 5. I'm subtracting, and in this rational expression, I have negative 3s minus 23 over s plus 5. Okay, so I am subtracting those two rational expressions. Again, notice the denominators are the same. So that means I can write this as one rational expression with that denominator. That's what that means. Now all I have to do is subtract their numerator. So go off to the side and do that. So I have s minus 3, subtract in parentheses this numerator. So a negative 3s minus 23. Okay? So that becomes very important that you do this. Then you subtract, then you distribute, and so you get s minus 3, a negative, or remember this one is to be a negative 1, so you can write this as negative 1 times a negative 3s. Or you can think of this as the opposite of a negative 3s, because remember subtraction means adding the opposite. So So the opposite of a negative 3s is a positive 3s, and the opposite of a negative 23 is a positive 23. And then combining like terms, I have s and 3s is 4s, a negative 3 and a positive 23 is a positive 20. And so that's the numerator. So the numerator is going to be 4s plus 20. So 4s plus 20. All right, what do you think the next step is? The next step is to factor, and then after that, it's reduce. So I can factor the numerator. So I can factor out of 4. So I get 4 times s plus 5, and that's being divided by s plus 5. And then what do you think the next step is? Next step is to reduce. Divide out your common factors. Don't forget to put factors of 1 in their place. And so you get 4 as the answer. Okay? Number 8. So number 8, we have x squared minus 8 divided by x squared plus 4x minus 12. So this rational expression, I'm subtracting from it this rational expression, which is 16 minus 2x divided by that denominator, that same denominator. So x squared plus 4x minus 12. Okay, so since the denominators are the same, I can write this as one rational expression. I'm going to put it down here. So write this as one rational expression with that denominator, x squared plus 4x minus 12. The numerator will be the difference of these two polynomials, the numerators. So go off to the side and actually work it out. So you have x squared minus 8, and then I'm subtracting this polynomial, which is 16 minus 2x. Now let's distribute the negative, or think of this as adding the opposite of each of these terms. So I get x squared minus 8 minus 16, and then the opposite of a negative 2x is a positive 2x. And then let's put this in descending order, combine like terms. So I get x squared. This is the only term with an x, so that'll be plus 2x. And then these are your constants, a negative 8 and a negative 16 gives me a negative 24. Okay? So that is the numerator. So the numerator is x squared plus 2x minus 24. Once you write this as one rational expression, the next step is to factor. So I'm going to go ahead and factor the numerator. The GCF here is 1, so I'm going directly to the two binomials. And so when I factor that, it looks like I'm going to get x plus 6 times x minus 4. The denominator, the GCF is 1, so I'm going to go directly to the two binomials. And when I factor that trinomial, I'm going to get x, looks like plus 4, nope, 6, plus 6, and x minus 2. All right? And then notice the next step after that is to reduce. And so when I reduce, I can reduce the common factors of x plus 6. Don't forget to put 1 to their place, because that's what that is. X plus 6 divided by x plus 6 is 1. And so I get an answer of 1 times x plus x minus 4 is x minus 4. And then 1 times x minus 2 is x minus 2. All right, so that was number 8. All right, so number 9. Let's go to number 9. All right, number 9, we have this problem. We have x squared plus 15 divided by x squared plus 4x minus 21. And I'm subtracting this rational expression, 11x minus x squared, divided by x squared plus 4x minus 21. All right, so I'm subtracting these two rational expressions. Again, notice the denominators are the same, so that means that I can write this as one rational expression. And the rational expression will have that denominator of x squared plus 4x minus 21. For the numerator, I need to subtract these two numerators. So do the work. So x squared plus 15, and then it's subtracting, notice the parentheses, this numerator. So I'm subtracting 11x minus x squared. And now I'm going to distribute, get rid of the parentheses. So I'm going to get x squared plus 15 minus 11x, and then the opposite of a negative x squared is a positive x squared. Combining like terms, I get x squared and x squared is 2x squared. minus 11x, and then plus 15. So just putting in descending order. And so therefore, that's going to be the numerator. So I get 2x squared minus 11x plus 15. All right, so once you write this as one rational expression, then you're going to factor. And so when I factor, the GCF is 1, so I'm going directly to the two binomials. I'm going to get 2x minus 5, it looks like, and then x minus 3. Let's double check that one. So the outer is 6x, negative 6x. The inner is a negative 5x, and I do get negative 11x, and then negative 5 times negative 3 is a positive 15. So that works out. And then the denominator, when I factor it, x squared plus 4x minus 21, I get x plus 7 times x minus 3. And then notice I can factor out the x minus 3's. The next step is to reduce, to simplify. And so the answer is 2x minus 5 divided by x plus 7. Okay? All right, so that was number 9. Let's look at number 10. So number 10, we have this problem. All right, we have 6y squared plus 6x squared divided by x squared minus y squared. And then again, I'm subtracting 12x squared divided by x squared minus y squared. All right, so I'm subtracting these two rational expressions. Notice the denominators are the same. So I have x squared minus y squared. All right, now let's get the numerator. So let's go off to the side and actually do that work. So if you look at the numerator, I have 6y squared plus 6x squared, and then I'm subtracting it. Now notice, you remember in the previous one, I put that in parentheses. I put it in parentheses because that was more than one term. When we did, if I can go back to the first few that we did, notice when I did these, I didn't put parentheses in number 1. I didn't put parentheses number 2, and that's because, remember, that was because these were monomials right here. So when we do number 10, notice I'm not going to put that in parentheses. I'm not putting 12x squared in parentheses. I'm just going to say minus 12x squared. All right. So parentheses is not needed here. Okay, now let's combine like terms though. So I'm going to get 6y squared. 6x squared and a negative 12x squared is a negative 6x squared. Okay, so that's my numerator. 6y squared minus 6x squared. Okay, now once you get to that point, once you write this as one rational expression, what is the next step? That's what you got to remember. The next step is to factor. So let's go off to the side and then factor this. So I'm going to go ahead and rewrite this over. And then let's factor this. So to factor this, it looks like I can factor out a 6, right? So I get 6 times y squared minus x squared. And then notice that's the difference of two squares. So I can factor that further. So that's 6 times y minus x times y plus x. And so that is the numerator. So that's going to go here. So that's going to be 6 times y minus x times y plus x. And then the denominator I can factor is, that's the difference of two squares also. So I'm going to get x minus y times x plus y this time. All right, so that's where I'm at. Okay, now let's reduce. The first factor I see is a 6. I don't see a 6 occurring as a factor in the denominator. The next factor is a y minus x. Now, I don't see a y minus x in the denominator, but what do you see? You see its opposite. So you see that y minus x, its opposite is x minus y. So you see its additive inverse. So those will divide out. Now be careful. Remember, don't put 1s in both places. Remember, they're opposites. So that means that one factor is 1, the other factor is a negative 1. And we tend to make the factor that's in the numerator the negative 1. And then the y plus x, do you recognize that that's the same thing as this one, right? Y plus x, same thing as x plus y. So those will divide out and you're left with factors of 1. And so therefore, if you look at the numerator, that's 6 times negative 1 times 1, so that's negative 6, right? The denominator is 1, so you just get negative 6. That's the answer. All right, so remember your opposites. Remember opposites. When you're dealing with these, sometimes you will end up with opposites. Okay, so number 11. All right, number 11, we have this problem. We have y squared divided by y squared plus 5y, and I'm subtracting 25 divided by, and then that's y squared plus 5y. Okay? The next, now remember, I'm subtracting two rational expressions with the same denominator, so that means I can write this as one rational expression with that denominator, right? And then the numerator, that's easy just to write out. That's going to be y squared minus 25. Okay, now once you write one rational expression, remember the next step is to factor. So I can factor the numerator, that's the difference of two squares. So I get y plus 5 times y minus 5. The denominator, I can factor out a y, so that's y times y plus 5. And then once you factor, remember the next step is to reduce, and I can reduce the y plus 5's here. So they divide out and left with factors of 1. And so the answer is y minus 5 divided by y times 1 is y. Okay? Number 12. Number 12, we have x squared divided by x squared minus 25, and then I'm subtracting 5x divided by x squared minus 25. All right, so again, it's kind of similar like number 11 in the fact that there's really no work to do on the side. You recognize right away that I can write this as one fraction with the numerator being x squared minus 5x, right? And the denominator is x squared minus 25. And now the next step is to factor. So when I factor, in the numerator I can factor out an x, and I get x times x minus 5. The denominator is the difference of two squares, so I get x minus 5 times x plus 5. And then it looks like the only factors I can reduce is the x minus 5's. And so you get x divided by x plus 5. Right. Number 13. So in 13, we have 6x cubed divided by x squared plus 4x plus 16. And I'm subtracting 384 divided by x squared plus 4x plus 16. All right, so again, if you look at this, the numerator is pretty easy to actually write out in one rational expression. That's 6x cubed minus 384. The denominator is going to be x squared plus 4x plus 16. Okay, now let's look at the numerator though, because remember the next step is to factor. So if I look at the numerator, I have 6x cubed minus 384. Okay, so notice that I have two terms, and then the variable x being raised to the third power. So you may want to check and see if you can possibly factor this using the difference of two cubes. Well, first of all, 6 is not a perfect cube, so it is possible that I can factor out a 6. And so using your calculator, you'll see that you can, that 384 is divisible by 6. And so when I factor out a 6, I'm going to get 6 times x cubed minus 64. That's what I get. And then notice that this is the difference of two cubes. Because remember, and I'm going to go off to the side and do that down here. I have x cubed minus 64. So if you notice that x times itself 3 times is x cubed, and 4 times itself 3 times is 64. So this is the difference of two cubes. And I can factor the difference of two cubes as a binomial times a trinomial. And so the binomial will be x minus 4. And the trinomial will be this squared, so that's x squared, and then plus, because it's always the opposite of this sign, plus the product of these two factors, so 4 times x, and then plus the last, so plus 4 squared, so that's 16. So that is this. So that becomes 6 times x minus 4 times x squared plus 4x plus 16. So that's your numerator. So I'm going to go ahead and rewrite this using that now. So that's 6 times x minus 4 times x squared plus 4x plus 16. Now remember, whenever you factor whenever you factor the difference of sum of two cubes, that trinomial you cannot factor any further. I mean, you can try, it's not factorable. Okay, so you see this right here though? That's this. So don't even try factoring this because that's the same thing as this and you cannot factor that one. So just rewrite it. But in the same way, the next step is to reduce your common factors, and those are common factors. That trinomial is the same as this trinomial. So those divide out. And so therefore your answer is 6 times x minus 4 times 1 divided by 1. So that's 6 times x minus 4. And again, leave your answer in factored form. Don't distribute. Leave it as it is. All right, so that's 13. Let's look at, I think that may be it. Let me just double check. Okay, so that's going to be the end of this lesson. So that should give you enough to be able to understand how to subtract rational expressions with the same denominator. All I need to remind you of those is this. So whenever you're subtracting a rational expression where the numerator is a polynomial with 2 or more terms, you need to put that in parentheses. And always do the work on the side and try not to do too much in your head with this part. All right, so that would be the end of this lesson.